Hi, my name is Steven. I'm from Belgium. Very excited to be here. And instead of all the other talks, I'm probably going to focus on. Well, yeah, I'll need to switch. So again, I need to go a little bit quicker. So instead of focusing on the technologies, I'll be focusing on how to get people excited about new technologies. One of the challenges I was facing a couple of months ago was how to explain Kubernetes or another complicated technology to a bunch of students that have never heard about Kubernetes before. So your first option is, of course, to create a PowerPoint, throw in some architecture overview, talk about the API, talk about the scheduler, throw in some YAML, and everything will be great and everybody will be excited. The result is probably something similar to this. So you need to come up with another idea. And one thing I remembered when I was learning Kubernetes was one of the talks by Kelsey Hightower, where he used Tetris as a reference for Kubernetes. So I thought that's a great idea. Let's level this up. And instead of taking Tetris, I used Gary's mod. For those who don't know Gary's mod, it's a first-person shooter that's highly customizable. And what we did is we added some Lua code so it could interact with Kubernetes, and we ended up with Gary's pod. I have a demo, but just to know, all the references and the links to the code is here. Now I need to. All right. So what we do now is we'll start up Gary's mod. We'll select a map, and we start the game. While the game is loading, we'll just do a kubectl get nodes, so you can see that in the back end, it's just a normal Kubernetes cluster running. It's running on GKE. We have 3 nodes. And after that, we'll just put a watch to see all the pods that are running inside the cluster. And as you'll see, there's nothing running in it now. So what we do now is we're going to connect the game to the Kubernetes API. We do it over localhost, so we need to set up a kubectl proxy. That's what we did now. And now the only thing that's left to connect the game to the Kubernetes API is open up a Lua script. So that's what we're doing now. And once we hit the submit, the game is connected to Kubernetes. So you saw that we had 3 nodes, and those 3 nodes are represented by the 3 fenced-off areas inside the game. So this is all good. So what happens now if we deploy an application into the cluster? So we have a deployment. It has 3 replicas. And once we deploy it, we'll see that the pods are started, and we can start seeing characters in the game appearing. So they all have their own, they're in their own area, so they're on their own little, their own node. So the next thing, what we can do is, of course, we can scale this up. So let's see, scale this up to 6. You can see the pods appear, and then you'll have some additional characters in the game. So what else can we do? We can also show how you do upgrades, because this is version 1 of the character, and we have a more sophisticated one. He studied, he's a professor, and he wears a white coat. So we update the image tag, and now you can see that we have new pods running with the new image, and it's also shown inside the game. Now we have the application running, and now the cool thing is, of course, because you're the administrator of your cluster, and your job is to protect the cluster. And from what you protected is, of course, from your enemies. So in the games, those are your enemies. But in real life, it's going to be disk failures, memory leaks, and things like that. So once I select my weapon, I'm going to spawn the bugs. And now restart the enemies. And as a cluster administrator, you're looking always over your cluster, and you see that you have one of the bugs that is actually attacking your application. So you need to work on it. But while you're fixing one problem, of course, on the other nodes, there's additional issues. So you need to have a closer look, and it's going to be very complicated to fix all the problems. But of course, because you're using Kubernetes, you can see here on the left that the pods are always running. That's it. Thank you.